Okay, in this video I want to talk to you about proteins and the natural food component proteins, which is a really important protein component because it has so many applications when we cook food. So it's really important that you sort of understand all of these. But first of all, I just want to explain a little bit about what proteins are. So we know that proteins are found both in animal and plant sources. Okay. The makeup of protein is that they're actually a strand of amino acids, okay? And it's like a strand like that, and all these things here are amino acids. And they're all joined together with bonds to make up a protein strand. So this whole thing is a protein, and it's a whole lot of little different amino acids. Now, all these amino acids are different. So we've spoken before about complete proteins and incomplete proteins. Now, complete proteins are found from animal sources, okay? And incomplete proteins come from plant sources. Now, what makes them complete and incomplete depends on what amino acids are in the protein strand. So as humans, we have certain amino acids that we make ourselves. And then we also have amino acids that we need that we don't make. Each amino acid, there's 22 different types of amino acids. So something that is a complete protein has all the amino acids available in that food source that our body needs. And something that is an incomplete protein, which comes from a plant source, doesn't have the amino acids that our body needs. Okay? So just be aware that complete proteins come from animal sources and incomplete come from plant sources. But when we're looking at diets, we can actually make incomplete protein complete by combining one or more of these incomplete together. So that might be, not complex, complete. Sorry, complete. By combining more than one, okay? So that might be, an example of that might be where we're looking at a dish that has, different types of beans in it and rice and some corn. And all those animal sources of proteins will make a complete protein. What we need to do is now look at what's happening with the protein when we're cooking it. So if I go back to our table here, we know that eggs and meat are our best sources of protein, and they both come from animal sources. So they are examples of complete proteins. And I'm going to just focus on these two for this video because they're the ones that have the most functional properties. So when we're looking at the functional properties, we're looking at denaturation, coagulation, and the Maillard's reaction. Okay, so I'm going to focus on these three reactions that happen. So if we have a look at our protein strand again, so it's made up of our amino acids that are held together with bonds. Now when we look at, sorry, I'm making everybody sick. Okay, so this is a protein strand. Now, when we process this during cooking, and it doesn't have to just be heat, it can be heat, it can be an acid, or it can be mechanical action. Okay, so that's something like beating, or when when we get our piece of steak and we bash it before we cook it, that's a mechanical action as well. What we're actually doing is we're breaking these bonds here, okay? And that process is called denaturation. So we're denaturing the protein strand. And the only way I can describe it is like we've got our bonds. It's sort of in a sort of semi-tight, sort of curling structure. But when we break these bonds, it actually relaxes the bonds a bit and it sort of stretches out a little bit. And that is denaturation. When we keep on processing it, the protein strands, which have had all their bonds broken, start developing new bonds, but at a much tighter, making it a much tighter structure. And this process is called coagulation. I've just spelt that wrong.
No, that's right.
That's right. Okay, cool. And that's called coagulation. So really, the two processes of denaturation and coagulation sort of go hand in hand, depending on what you're doing to it. Okay? For some, you might want to stop at your denaturation process. So that would be something like if you just put lemon juice on a bit of chicken for a very short period of time, you're just relaxing the meat and making it more tender, and then you might take it out of that lemon juice, the acid, and then so the process stops. But then when you cook it, the heat will continue and it will go into coagulation. So that's why things like meat, when they cook, they shrink in size, because if you can imagine that, the bonds are getting tighter and tighter, so it's pulling the molecules together and it's actually squeezing the water out. If we keep the process, like if we keep the heat or we keep beating it or we keep it in the acid, it will get tighter and tighter and it gets drier and drier. Okay, so it's really important that these two processes of denaturation and coagulation, it's a one-way process, which means it can't be reversed. So once a protein has gone through the process of coagulation, it can't go back to what it was before. So you'll notice that in the chemical and physical changes that are happening, that once that's happened, it will never be the same. So the perfect example of that is an egg. So an egg in its raw state is translucent, which means that you can sort of see through the egg white, and that's because the protein strands are fairly loose, so the light can go through them, okay? But when we start cooking it or beating it, and we do the denaturation and the coagulation, these bonds start forming new, they become tighter, and the light can no longer go through it. So there is a physical change of colour from that sort of see-through yellowy colour to something that is completely opaque, which means you can't see through it and it's white. So that's the physical change that's happening, and the chemical change is what I've just described here. Okay, and it's really important to, once you've cooked an egg and it's gone from a liquid to a solid, it will never go back to a liquid. Also, when you beat egg whites, you'll incorporate the egg. It will go into a white colour. Now, sometimes if you leave egg whites, some of the liquid will come out of that and sit down the bottom. That is not a reversal in the process, because if you got that liquid again and tried to beat it, it wouldn't beat because it's already gone through the process of coagulation. Okay, the last one I want to look at today is the Maillard's reaction, which is the reaction that happens with protein and dry heat. Okay, so we all know that Maillard's reaction happens with dry heat. And some examples of this is one of the things that we look for is the browning of the product. Now, for Maillard's reaction to happen, we need a couple of things to be present. So we all know that the most important one is the protein. Okay, so there must be protein present. And then we know that it has to have dry heat, but we also know that what has to be present is either a sugar or a starch. So when we're looking at some examples of this, it can encompass quite a lot of different products. So it could be the browning that happens on steak when we cook steak. It can be the browning on the top of a cake when it's in the oven. It can be the browning of a glaze when we put an egg glaze on some pastry. So these are all examples of Maillard's reaction. Even when we put toast into a toaster, sometimes there can be some Maillard's reaction because it's dry heat. In the toast there is starch, and if the product has a protein in it, which flour does have a protein in the form of gluten, then Maillard's reaction will happen. So when we're looking at browning of these products, it's really important that it can be dextrinization and Maillard's reaction, okay?